Hi students, welcome back to my channel CSIT tutorials by KanyaKumari. In this video we are going to discuss NFA Epsilon moves to NFA without Epsilon moves. What is meant by Epsilon move? Epsilon move is nothing but, here it is saying moves. That means we will move from one state to another state. That is move. Why it is epsilon? Generally epsilon means nothing. Nothing. That means we are not processing any input. We are not processing any input. That means without processing the input symbol, if we want to change from one state to another state, this epsilon moves are used. Okay. So, if NFA consisting of epsilon moves, then how to convert into NFA without epsilon moves. So, that procedure with an example we will discuss in this video. Now, for example, now the states here are Q0, Q1, Q2 is the final state. Three states are there. Q0 is the initial state, Q2 is the final state, epsilon, epsilon. Now here it is A, B. For example, here it is C. Three input symbols are there. Okay. Now see what is the meaning of this. Any number of A's you can have. Any number of B's you can have. Any number of C's also you can have. That is the meaning of this transition diagram. That means minimum string is epsilon. See, without processing any input symbol, with epsilon move you can reach to here. With epsilon move you can reach here. Okay. So, here minimum string is epsilon. Next, you can have any number of A's, any number of B's, any number of C's you can have. Okay. Now, for example, now this is the finite automata NFA epsilon moves. Now, what is the procedure for this conversion? The procedure here it is. First, we have to find out epsilon closure. Epsilon closure of each state we have to find out. What is our first step? We have to find out epsilon closure for each state we have to find out. So, in our example, so I am writing epsilon closure of Q0. Epsilon closure of Q0. Similarly, epsilon closure of Q1, epsilon closure of Q2. So, these two also we will find out. Epsilon closure of Q0 is, what is meant by epsilon closure? Epsilon closure of, how to find out? From this state to all the other states which are having epsilon move. Is it clear? I am repeating it again. How to find out epsilon closure of a state? So from the given state to the states which are having epsilon transition. That means consider Q0. Q0 from that state, so Q0. So it is going to which state with epsilon transition? It is going to Q1 state. Next it is going to Q2 with epsilon. It should have epsilon transition. Next, epsilon closure of Q1 equal to, starting from this state. So, Q1. So, Q1 comma, with epsilon transition it is going to Q2 state. Q1, Q2. Next, epsilon closure of Q2 equal to Q2. Okay. So, like that, in step 1, epsilon closure of each and every state we have to find out. Next, New transitions we have to find out. That means NFA without epsilon also. How to find out the transitions for that. So that is our step 2. In step 2, what we will calculate? In step 2, the new transitions. That means NFA. This is simply, you can say that NFA epsilon mode. Without epsilon modes means simply you can say that NFA. Okay. So now, how to find out the transitions? So the transitions here are, for differentiation purpose, you can take them as delta cap of Q naught with what is our input alphabet? A, B, C. Okay. So Q naught with A we have to find out. Q naught with B you have to find out. Q naught with C. So likewise totally 9 transitions we have to find out. Q naught with A is, see how we have to calculate it. Epsilon closure of delta of epsilon closure of Q naught. This Q naught here we will get Q naught with 0. So that equal to epsilon closure of delta of epsilon closure of Q naught is Q naught, Q1, Q2. Q naught, Q1, Q2 with 0 transition. That is epsilon closure of this. How to find out? Delta of Q naught with 0 union, delta of Q1 with 0 union, delta of Q2 with 0. Epsilon closure of Q naught with 0. Oh, okay, here it is A, no? Not 0. Q naught with A, Q1 with A, Q2 with A. Now, Q naught with A is, it is Q naught union. Q1 with A, there is no transition, fine. Q2 with A, there is no transition. So that means, I am writing shortly, epsilon closure of Q naught. Epsilon closure of Q naught is Q naught, Q1, Q2. Okay. So, this I am writing in a single box. I will put for identification. That means here we can write like transition table. We can write Q sigma. This is NFA transition table. Parallelly I am representing. Okay. Q naught with A with B. Q naught with A, Q naught, Q1, Q2. Okay. Next. Similarly, we have to find out Q naught with B. We have to find out. See, Q naught with B. Q naught with B. Q naught with C. Now, here itself you can write, otherwise I am writing separately. Suppose here you can write like, there will be a confusion, no problem, I will solve it. Delta cap of Q naught with B is nothing but epsilon closure of delta of epsilon closure of Q naught with B. That is, all these things are same, na? See, while watching this video, you to solve it parallelly with me. Then it is easy to understand. So it is not like simply a normal video. So this is a problematic subject, na? So with me, parallelly, you to solve in a book, okay? Then it is easy to understand. Transition of epsilon closure of Q naught is Q naught, Q1, Q2 with B. This is nothing but epsilon closure of delta of Q naught with B union, delta of Q1 with B union, delta of Q2 with B. So epsilon, you write fully, na? I am writing shortcut, okay? Shortly I am writing. Q0 with B. See, Q0 with B, there is no transition. Fine. Q1 with B. Q1, Q2 with B. Fine. So that means epsilon closure of Q1. Epsilon closure of Q1 is, already we have solved. That's why in step 1 we have calculated epsilon closure. Epsilon closure of Q1 is Q1, Q2. Q1, Q2. Similarly, see here I am writing Q0 with the C. Q0 with the C. 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 Okay. So you write on Q0 with the C, 5. Q1 with the C, instead of this 5. Q2 with the C, it is Q2. So epsilon closure of Q2. Epsilon closure of Q2 is Q2 only. So here it is Q2. Hope you understand that. Okay, right. So now, similarly, what we had to calculate now? Q1. We have to calculate Q1. So how to calculate Q1? So I am erasing here. Now it is here what we have to calculate? Q1 we have to calculate. So Q1 with A. This is epsilon closure of delta of epsilon closure of Q1 comma A. That is epsilon closure of Q1 is Q1, Q2 with A. That means epsilon closure of I am writing directly Q1 with A. Q1 with A, 5 union Q2 with A. See? Q2 with A. Q2 with A is also 5. Okay? That is nothing but 5. There is no transition. Okay? Similarly, next one is Q1 with the P. With the P. With the P. Q1 with the P. Q1 with the P. So it is not 5. Q1 with the B is Q1 union Q2 with the B. 5. That means here epsilon closure of Q1. Epsilon closure of Q1 is simply Q1, Q2. Here it is Q1, Q2. Okay, next Q1 with C. I am taking another color. Next, it is C. It is a C. Here it is a C. Same state, na? Only C. Input is changing. Here it is next of bit is C. So Q1 with C. Q1 with C. So now I am erasing these things. So now see this. Epsilon closure of Q1 with C, 5 union Q2 with C, Q2 is there. So then simply epsilon closure of Q2, which is nothing but Q2. Students, I am telling you again, you solve with me parallelly. Then it is easy to understand. Don't just watch the video. Okay, solve with me. Then only you can easily understand. Now, next state is Q2. I am erasing this part now. The same thing you try to solve and then verify. Now, now transition of Q2 delta cam Q2 with A is epsilon closure of delta epsilon closure of Q2 comma A, which is nothing but epsilon closure of delta of epsilon closure of Q2. Already we have calculated now. Q2 with A. Epsilon closure of Q2 comma A. Q2 with A is 5. So here it is 5. Next, Q2 with B. Q2 with B. Q2 with B. See, Q2 with B is also 5. Next, Q2 with C. 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 Q2 with the C is, it is not 5, it is Q2. Epsilon closure of Q2 is Q2. So here it is Q2. So this is your NFA. Now see. So here observe here what we have done. Simply I am telling you, simply our first step is find epsilon closures. Second one is NFA transition table. And then we will represent NFA transition diagram. Is that clear? Now, the new point here it is, which one we have to consider as the final state. Now, already Q2 is the final state. So, in NFA without epsilon moves also, Q2 will become the final state. Including this Q2, so F dash is a new final state. So, existing final states union Q naught. If epsilon closure of Q naught consisting of F. If epsilon closure of initial state consisting of the final state, then we will make Q naught is also as a final state. Consider our example, epsilon closure of Q naught consisting of the final state Q2. So Q naught is also a final state, remember. Now NFA without epsilon moves, we got two final states. Originally it is having one final state. NFA without epsilon moves, two final states. So if you don't understand this one, again you move back and watch the reason. So this is the final state finding in NFA without epsilon moves. Hope you understand, students. So solve this problem with parallelly with the video and take your own example and solve it again. If you have any doubt, you please send me message in the comment box. Thank you, students. So if you want more videos, so you please subscribe to my channel. Thank you, students. Have a great day. Bye.